talk about bread, and in particular about bread baking. So first, I would like to start with the motivation and a short introduction of our starting project. Uh, as you know, the bread baking is really old. In fact, it's like known for thousands of years. But however, still today, we know our our knowledge about this very difficult and complex process is very limited because of the difficult and complex physical and chemical interactions, like internal and external heat transfer interactions with complicated chemical reactions. And therefore, even today, cook and look method is the most common method for baking optimization in the industry. And our goal is to change this. In particular, we are starting a new project of Czech National Agency for Agriculture Research that will be focused on optimization of energy consumption during the baking. And when I say we, I mean a relatively wide spectrum of collaborators. I personally am from a Department of Mathematics, Informatics and Cybernetics of University of Chemistry and Technology. Our department, together with the Department of Chemical Engineering, should be responsible for the modeling part of the project. Then we have collaborators from Department of Carbohydrates and Cereals that will take care about experiments and measurements. We have also collaboration with the industrial bakery. That is great because they will allow us to validate our models in real life industrial ovens. And we also have a collaboration with the industrial oven producer. So the overall goal of the project is to optimize the oven temperature during baking, so-called baking curve. And to do so, we would like to develop a really cheap and fast reduced order model using standard techniques of reduced order modeling, like proper decomposition. Maybe you know it as singular value decomposition, coupled together with neural networks and used for interpolation of the coefficients. But of course, for this reduced order model, we firstly need a validated CFD model of the process, and that's the thing that I will talk about today. As I've already said, bread baking is really physically complex. We have to deal with external heat, mass, and momentum transfer inside the oven. Then this interacts with the internal heat and mass transfer in the bread and with the chemical reactions inside. And of course, with the bread deformation that is caused by CO2 formation during chemical processes. As this project just started, actually it started in April, so it's really new. We firstly are looking to understanding of the internal processes inside the bread. So today I would like to talk about our initial steps towards modeling of this internal transfer, neglecting the bread deformation, and accounting for external heat and mass transfer only effectively in boundary conditions. So to have a look at governing equations of the developed simplified model of the internal transfer, first from our literature study, we found out that a Peclet number inside bread is relatively small. That means we can neglect convective heat transfer inside bread, so the heat or enthalpy balance can look as this, where K are individual phases in the system. Furthermore, heat conductivity or effective heat conductivity is calculated this simple only as volumetric mean of heat conductivities of individual phases. Right hand side of the enthalpy balance is just the source of heat caused by evaporation or condensation. This m.ev is the evaporation rate that I will talk about in a minute, and delta HEV is evaporation enthalpy. Considering mass transfer, the first thing that I would like to emphasize is that as we do not assume bread deformation so far, the CO formation and transfer is not very interesting and important, and really from our point of view, only water transfer and evaporation inside bread is important. So we are only solving for a mass balance of the water liquid and water vapors. Again, here is evaporation rate that is defined like this, where C, I don't have like laser maybe, and C is a constant taken from this work of Al-Nasser, and T set is the saturated temperature at local vapor pressure. With the model, we can move to validation. We validated our model against experimental and numerical work of Chang from 2005 and of the numerical work of Al-Nasser from 2021. And we just work with the simple geometry of or axisymmetric geometry of the bread. Initial conditions are set according to experiment, and boundary conditions are Robin boundary conditions that represent the equality of the fluxes of the internal and external fluxes. Firstly, here we have comparison of the temperature in the center probe and the surface probe during baking. We can see that the model predicts the results quite good, especially in the center. The discrepancies in the surface temperature, we believe that these are caused by effects of the crust formations at the surface. This statement can be further supported by the results of Chang simulation, who included also bread deformation and crust formation inside the model. I mean, we can see that his temperature at the surface gives better results. So we believe that this effect is caused by this crust formation that we are not assuming so far. So we are very happy with these results. Also, the total moisture content depends on baking time, or our results are really good. Honestly, we were really surprised by this result, because it seems that our model is even better than the simulation of Chang, who, as I said, included also bread deformation, crust formation, and so on, and we have a really simple model. So we plan to make some additional experiments to check whether if it's not possible that our model is maybe overfitted with these coefficients, with these heat or mass transfer coefficients. So we will check it, but so far it looks very nice. The last but not least result that I would like to show is quantitative profiles inside the bread during baking at time in the 1st and 4th minute. Again, comparison with the work of Chang. Unfortunately, he does not have values on the left axis, so we can't compare absolute values, but it seems that quantitatively the at least trends are quite similar. So that's the end of my presentation. I would like to summarize. We have developed a simplified model for internal transfer inside the bread. In the nearest future, we would like to perform some additional laboratory experiments to validate whether our model isn't overfitted, and of course extended by the bread deformation and crust formation. That's all from my side. Thank you for attention.
Thank you for your very interesting talk. And now we are open for the discussions.
Thank you for your very interesting presentation that comes from our daily life. And I have one question about, as we all know, the bread, there's many holes that is generated when the bread is baking. So I'm very curious about that. If the holes that's generated when through baking, it generates randomly. So will the holes that will affect the comparison with the simulation and the experimental results?
Of course, you are right. The bread itself is very porous medium, so all the transport parameters are very sensitive to this porosity and so on. Actually, in our model, we assume the porosity to be the same all the time and inside the whole bread. And the results are not so bad, but we definitely want to, when we add this bread deformation because of formation of CO2, we definitely want to have some porosity profile, because where the reaction of or formation of the CO2 is the biggest, there will be, of course, the biggest pores and so on. So we want to have a profile of porosity inside the bread and also, of course, inside in the time. But so far it's constant and the results are not so bad. So maybe it will be enough like this. I don't know actually, but yeah, definitely it's a good point and we want to include it. But so far it's not there.
Okay, thank you.
Okay, any other questions? So it's a very interesting talk we can hear before the banquet. And I have a question. Yeah, last question, okay? And I think we can still have some time. So did you in your conclusion or your future work, you think you are considering the bread deformation, right? So did you have some solutions to conduct these kind of calculations?
Yeah, so far it's just starting process. So far, no, but this work of Cheng, he assumed all these bread deformation based on internal stresses inside the bread. And I would like to copy his approach. So I hope he did it in finite elements, but I hope I can like take his at least like approaches and somehow connected with OpenFOAM and yeah.
Okay, thank you. And if there's no questions, then I can thank the speaker again.
Thank you.